Hey guys, welcome back. So this is our lab 3 recording. So this is about the density lab. You probably don't need any help from me, but I just want to walk through a couple of things with you. I'm going to go ahead and share my screen so that we can talk about that. The main purpose of having you do this experiment, Alex, is to show you some of the things that we would be doing if we were in a physical lab. It is not always possible for us to know exactly what the volume of a material is. Things are weird shapes, and sometimes we can't do that, or we need a more precise measurement of what exactly that looks like. The way that we deal with that is to do the techniques that you're going to be studying in this particular experiment. So, dealing with measuring by difference, dealing with measurement of volume by water displacement, which of course is a very famous way to do this. All of that should be stuff that you need to see. Now, we do sometimes forget or not specifically use the tare on the balance. And so we need to be able to measure something that's in a container, have a weight for that container, and then have a weight for whatever we've added to that container, and take the difference of those two measurements to be able to see what the mass of what we've added is. That's important. Typically, that is done when we're doing an experiment and we've actually changed the properties during the course of that experiment. And so what we'll have a vessel that we put things into to do the experiment. So we'll have a mass at the beginning, but then we'll have to not take into, so we can't tear out the weight of that vessel, because we're going to have that weight when we do the second measurement. So it's going to have to be this, a secondary measurement. And the easiest way for us to do that is to make sure that the balance is tared on its own, and then we use the same vessel when we do that experiment. So that we have the same mass before and after. Okay, so it is necessary for us to be able to do that from time to time. Knowing when to do that is kind of a tricky thing, but that's okay. You can always ask somebody else, because that's the way I always do. So I'm going to go ahead and enter the student view so that we can talk about what's in here. There's not much to this experiment other than doing what they tell you to do. The big things that we find to be issues in working with the virtual labs, and there are a couple of them, is that it's looking for a different number of sig figs than what you think it should be taking. So I will apologize, because I think it's ridiculous, but Alex is not great about asking for what I think are the correct number of significant figures. There are a lot of different people who went into the programming of this, and not every type of chemist pays the same kind of attention to sig figs. So if you have somebody who did a particular experiment, who wrote that experiment, and they're not great at paying attention to that, they may have just decided, I'm going to drop it off here, or I'm going to require more here, even though that's not really what's supposed to happen. I have complained about this to the company that makes these to try and get them corrected, because I think it's important that we teach you the correct number of sig figs as we go through. But that is one of the biggest complaints. So you'll find that it's not consistent as to what it's looking for, and I apologize for that. When you come in to this particular experiment, there are going to be questions that you'll need to answer before you can continue. Make sure you go ahead and answer those. If you get them wrong, you get them wrong. You can do this again if you choose to. You have unlimited attempts on any of these experiments. So if you're looking to do it again to get a better score, you are more than welcome to do so. Okay. So it's very straightforward as to what it's asking you to do for this. So pick this up, we put it on the balance, woohoo! I have to record that number. And this is what I was talking about not having tared the balance or not done it appropriately. Oops, I forgot about that. So again, making sure that you've done exactly what it's asking for is a really big deal. It's also kind of picky about where you click things. So it may be that you're trying to click something and it's not taking it. Just keep trying to click around because it may be that you're trying to pick up something that's here and it thinks you need to be over here. I don't understand why it's like that, but it does. Again, density is something that we often need to deal with. And density is something where it's mass per volume. And based on that mass per volume, we can find that things that are more dense will come down, things that are less dense will float, things that are about the same density will be suspended. Okay, so we can figure out what the density of something is even without being able to directly measure its weight and volume by using combinations of solutions to do this. And from time to time, we have to do that, especially when we're talking about the density of a liquid, because we can't take the density of a liquid and measure its mass and its volume very easily. So we need to be able to find other ways to deal with that. So that is one of the things that you'll be observing when you do this particular experiment. This is actually how I don't know if you've ever seen them, but the thermometers that have different colored liquids where each one has a different ball and it moves depending on what the temperature is. That's how that works. It's based on the gradient of density that you see. So as the temperature goes up, the density changes. And so we have different densities of solution of liquids that are in there, and therefore it moves as the temperature changes. I think it's really fun. I have one of those. So there you go. But that's what we're dealing with here. Now, you need to do the density portion, so this experiment. And again, you have as many tries as you want if you need to do it again. If you run into something that you cannot figure out that's giving you issues, talk to me about it. I'll see what I can figure out. And it may be one of those things where you and I need to sit down and do it together. And that's okay if that's what happens. After you've done this portion of it, because I'm going to go ahead and submit this for partial credit. Once you've done this portion of it, there is always a quiz that is the post lab. So you'll see there's a post lab. This is for the lab skills. And there's a post lab for density. And this is a quiz that you need to take. You have 2 times that you can take this. Okay, you take it the first time. And then if you decide to take it again, you only take again the questions that you missed. So you have two opportunities to do that. You are given 1 hour to do that quiz. Okay, and all of that is right here. So you can see that those points you will, based on how you answer that, you will get those. Okay. I think that's everything I had to tell you about that particular experiment. It is extremely straightforward, as I mentioned, so I wouldn't expect too many problems. And again, this is to show you as best as we can some of the things that we have to do in the physical laboratory when we need to make measurements that are not that easy to make. Okay, so that's what we're doing with that. So that's this one. I will have another recording for the next lab that you guys have, which is sort of a review of everything that we've done to that point. The material that's in it right now is not completely relevant because we haven't balanced equations yet. So, but I will have that posted, and then hopefully the rest of these will be posted in the next week so that you will have them available. If you have any questions, comments, problems, concerns, anything at all, let me know. WebEx, talk to me during class, send me an email. It's all good. All right. Thanks, guys. I'll talk to you later.